A problem with all hobby-sized milling machines seems to be that there isn't very much Z-height. If you have a fairly tall fixture, like a rotary axis, this can become quite limiting. Here we see that I can barely fit a 3mm drill into the chuck. And this is partly because the drill chuck is rather long. I used to have a slightly shorter one, but this happened to it. I sourced a chuck for £14 and a shell mill arbor for £17 from eBay and shopapp.co.uk respectively. This is a 3D model I used to work out how to modify the parts. This is the internal drill arbor taper that is intended for attaching a standard shank. It isn't immediately obvious because of the way that they fit together, but the end cap unscrews. I held the end cap in the lathe chuck and used a hook spanner to remove it. The jaws hook into an actuator with the left-hand thread. And holes in the guide body allow clearance for the hooks. I cut off as much of the guide body as I thought I could get away with. And modelled up the modifications required to the shell mill arbor. The original way that the drill body was retained on the shank was with a threaded ring and ball bearings. I have removed the possibility of using the same method, so the parts are retained by the actual ball bearings. These bearings are fed in through a drilled hole that I didn't bother to model. I started off by machining the guide body after carefully centering it in the 4-jaw chuck. I used the original arbor piece to provide tailstock support during the initial turning. I decided that coolant was needed, but then found the nozzle was blocked. chamfers, I have a special sleeve to hold BT30 spindle tooling in the lathe spindle. There is a dot mark that should always align with the 1 mark on the spindle. The spindle on this lathe has an electromagnetic brake. We won't need the drive dogs. I had terrible trouble with birds nesting. I could not get the chips to break. Fast forward. I decided I could steal a bit more length and move the flange back another couple of millimetres. Still with the bird's nesting problem. Now to shorten the spigot and hopefully lose the 12mm I want myself a right hand thread, as I need the left hand thread. It's a pity about the through hole that was left behind, but that got removed later when I revised the length. This is a special lathe file. The teeth are more angled. Then machine to final size for a tight sliding fit. Polish with emery to final fit. This needs to turn smoothly, but it is all that aligns the drill. The Jacob style chuck is better in this regard than the Albrecht style, as the tool shank and the jaw guide is one solid piece of metal. Out of focus relief groove cut by hand wheels. I used the lathe to start the tap square. I finished the tapping by hand, and it was a real struggle. I suggest you buy a really good quality tap if you try this. Trial assembly showed that more space was needed for the actuator head, so the spigot was shortened. So we lose the ugly hole remnants at least. I could just fit the 3.1mm drill in with the current chuck to drill the hole to fill the ball bearing groove. The hole was placed in a position where the chuck cap piece would retain the balls. Here I am making sure that the drill is retracted just far enough, in the most dangerous way possible. Using a feeler gauge as a spacer, I drilled a small mark to locate the matching ball bearing track. The chuck and the workpiece were transferred together to the lathe. Then I spent ages trying to find a tool to cut the groove. Before giving up and grinding a special out of a broken carbide end mill. I checked the alignment with a 2-micron indicator, as it is fairly critical. The internal groove was cut by hand and checked with a ball in the groove and an internal micrometer. But this wasn't filled competently. The tool was reversed in the holder and the groove was iteratively aligned with the drill mark by eye. A blob of grease holds the ball bearing in place to be measured with a micrometer. and then a test fit with a single bearing, so that it is easy to dismantle. And then it's time for the final assembly. Old and new chucks, showing the length difference. Also, the new one is 16mm, whereas the old one was 13mm. Admittedly, this shaft vise is a bit oversized for this machine. But with the old chuck, I can't get the drill in. Whereas with the new chuck, I can.